Hi, I'm Andrea Santos.
I'm Ashley Foster.
And we did our experiment on determining the toxicity of ethylene glycol on lolium multiflorum. Ethylene glycol is an item commonly known as antifreeze. It is used as a coolant to ensure the proper running of automobiles. Although it is a very useful item, little is known about what its effect is when it's infiltrated into the soil. One thing that is known, however, is that ethylene glycol can affect the gastric system of certain organisms, like rats. According to the MSDS form for this product, when ingested in humans, it can cause kidney damage and metabolic acidosis. Studying the effect that this product can have on the environment will help kind of make us more careful of what we're doing, especially when doing everyday tasks like working on our cars. Based on its toxicity to humans, it was originally hypothesized that 10% of the 50-50 solution would kill off all plants, and that at around 4%, half of the plants would show a significant change in the height. The plants used for this experiment were lolium multiflorum, which is a grass. To begin this lab, 15 pots were selected for the experiment. Each pot was filled about 3/4 of the way full with Garden Magic potting soil. It was decided which concentrations of antifreeze should be used based on the potential harm that they would cause lolium multiflorum, and it was decided that we would do 2%, 4%, 7%, and 10% solution, along with 3 control pots of just water. Each concentration was designated 3 pots in order to get more thorough results. For each pot, the soil was placed in a plastic container and mixed with the proper concentration of contaminant and water. Each pot had 50 milliliters of solution added to the potting soil. Once thoroughly mixed, the soil was placed back into the pot and labeled with whatever the percentage was of the antifreeze that was added to it. The container in which the soil was mixed was washed and dried between each trial so that we didn't have any extra. To add the contaminant, a 2 milliliter pipette was used. For the water, a graduated cylinder was used. Once all of the soil was mixed, repotted, and carefully labeled, 10 seeds were placed in each pot. The pots were then all placed in the greenhouse in order for them to grow. They were monitored for 1 week. Throughout the week, we regularly checked the plants to see if they needed water, and when they did need water, we added the same amount to each pot. On Monday, we added 20 milliliters of water, and on Tuesday and Wednesday, we added 10 milliliters. At the end of the week, the blades of grass were measured to see what the effect the ethylene glycol had on the lolium multiflorum plants.
Initial results of this lab were even less than expected. Other than in the control, there was little growth. Because of the lack of growth, the experiment was conducted once more. The average growth is provided in Table 1. For the control, the average growth was 7.72 centimeters. For 5% concentration, the average growth was 7 centimeters. For 10% concentration, 7.04 centimeters was the average growth, and the average growth for 15% concentration was 5.75 centimeters. Based on the results, it is evident that the ethylene glycol had an effect on the mean growth for the 15% concentration. The mean in this control was 7.72 centimeters. In the plants treated with antifreeze, the mean was only 5.75 centimeters. The result of this experiment showed that the ethylene glycol does in fact have an effect on the environment, and the LOEL is 15%. Based on these results, ethylene glycol has the ability to have a negative effect on the environment. The p-value for the trial was 15%, concentration was about 2%, meaning this is significant. The p-values for the other trials were around 20%, which means that they are not significant. We were limited in this experiment because of the growth of the seeds depended on so many different factors. For instance, the soil quality, soil moisture, and the heat in the greenhouse. For the future, we believe it would be beneficial to do this experiment on a larger scale with more concentration levels, so that we could pinpoint the exact value for the lowest observable adverse effect level.